Hi all, I'm here with a new course, Power Electronics. Those who have studied BTech EEC or BSc Electronics may already know the content of the course. But those who are going to learn the course will be enthusiastic to know what is the nature and content of the course. So let me explain through a few slides regarding the nature, scope and application of the course. So what is Power Electronics? It is a combination of three words: power, electronics and control. Power electronics may be defined as the applications of solid-state electronics for the control and conversion of electric power. It is a very interesting, important and relatively one of the easiest subjects. Basic requirements are KCL, KVL, that is what you have learned in your network theory, behavior of L and C in both DC and AC. You should have a basic knowledge in following subjects: circuit theory, power semiconductor devices both analog and digital, machines, power system, control theory, microprocessor and microcontroller. Of course, power electronics is multidisciplinary in nature, need knowledge in all branches of electrical engineering. To show the impact of power electronics in our daily life, I can cite an example of the fan regulator. Earlier, the fan regulator was big in space. You can see in the picture. If we keep in low speed for a long time, heating will occur. After the introduction of power electronic circuitry, emerged the new type of fan regulator with very less heat dissipation, smooth variation of speed, small in size, just one knob, you can see in the picture. So, from a massive regulator to small, elegant regulator. You might have heard about HVDC transmission. Instead of transmitting AC power, we can transmit DC. There are many advantages for this DC transmission, including reduction in losses. This HVDC transmission was realizable only with the help of power electronic circuit. You can see in the diagram rectifier and inverter both belong to power electronic circuit. Now the question is, how power electronics is distinct from linear electronics? You might have already learned other electronic papers and you may be thinking, why to learn power electronics separately? What is the difference actually? First, you should note that it is not primarily in their power handling capacities. In power electronics, all devices are operating in the switching mode, either fully on or fully off states. But the linear amplifier or the linear electronics devices concentrates on fidelity in signal amplification and requiring the transistors to operate strictly in the linear zone. So in power electronics, we are preferring the switching operation, and you can see in the diagram, you can see the red lines, and power electronic devices operate in the on state or in the off state, not in the linear region. So here are some differences listed between linear operation and switching operation. Linear operation will happen in active zone. Switching operation will happen in saturation and cutoff zones. Power electronics involves the study of power semiconductor devices, their physics, characteristics, drive requirements, and their protection for optimum utilization of their capacities. Power converter topologies involving the control strategies of the converters, digital, analog, and microelectronics involved, capacitive and magnetic energy storage elements, rotating and static electric devices, quality of waveforms generated, electromagnetic and radio frequency interference, thermal management. Now we will look into the course objectives and course outcomes. Course objectives are to get an overview of different types of semiconductor devices and their switching characteristics, to study the operation and characteristics of various types of power electronic converters. The expected outcomes are, by the end of the course, the students will be able to choose appropriate power semiconductor devices in converter circuits and develop their triggering circuits. Students will be able to analyze various types of power electronic converters and apply different switching techniques. Students will be able to select appropriate power converter for specific applications. Students will be able to interpret and use data sheets of power semiconductor devices for design. I hope everyone who watched the upcoming videos on power electronics will be able to achieve the outcomes at the end of the course. I will be uploading more videos on power electronics soon, and those who have not subscribed my channel, please do subscribe. Thank you.